Good morning to everybody. Today we are going to presenting about the direct sequence break spectrum DSSS modulation technique using shift register sequence. And my group have three members, who is me, Yap Seng Zong, Nguyen Yu Long, and Nicholas Si Ting Ki. And this is the picture of us with the FKKK background in new time. So for the introduction part, a modulation technique called direct sequence spectrum (DSSS) is employed in digital communication system to improve signal security and robustness. DSSS reduce interference and enhance resistance to eavesdropping and jamming. This paper offers a comprehensive analysis of DSSS, outlining its benefit, uses, and working principles. Additionally, examine is the performance of DSSS in a variety of communication contexts, including military and wireless network. And for the further introduction to DSSS, the fundamental idea behind DSSS is to employ a high-rate chipping sequence to lower the spectral density of the signal by spreading its power over the large bandwidth. Then, in order to effectively spread the signal throughout a considerably wider frequency band, the DSSS multiplies the data stream with a pseudo-random noise (PN) sequence. This spreading improves privacy by making the broadcast harder for unauthorized receivers to identify, in addition to strengthening the signal's resistance to multipath, faded, and narrowband interference. And in this assignment, the core concept of DSSS are explored, along with its theoretical foundations, real-world application, and communication scenarios performance.
DSSS improve signal security and reduce the interference in digital communication. So in the DSSS transmitter, original data is mixed with the PN sequence to split the signal over a wider frequency band. This split signal is then modulated onto a carrier wave and transmitted. So next, at the receiver, the incoming signal is demodulated. The same PN sequence is used to separate the original data from the split signal, effectively filtering out the noise and interference.
Hi, my name is Nicholas. Today, I will give a brief explanation on this MATLAB coding for the DSSS direct sequence spectrum modulation using a shift register sequence. So the first part of the coding is defining the parameters such as bit rate, chips per bit, message length, and PN code length. After that, we randomly generate message signal and PN code sequence using a custom LFSR function, which is a linear feedback shift register function. So this LFSR function is at the bottom, which is this one. After that, to match the length of the message signal in chips, we have to extend the PN code. After that, we outsample the message signal to match the chip rate. And we can perform the DSSS modulation now by storing the outsample message with the extended PN code. The following part is the simulation of the transmitted signal without adding noise. In order to cover the original message, we have to distract the received signal by using the same PN code. So the last part of the coding is plotting. We generate time vector and plot the signal for visualization. When we run this code on the MATLAB, so here is the result of it. So first, let's look at the top plot, which shows the original message signal. This is a simple binary sequence we generated randomly. The second plot displays the PN code generated using a linear feedback shift register, LFSR. This code is crucial for spreading the message signal. In the third plot, we see the DSSS modulated signal. This signal is the result of SOR operation by upsample message signal with the extended PN code. The fourth plot shows the received signal. In this simulation, we assume no noise during transmission. So the received signal is identical to the DSSS modulated signal. Finally, the bottom plot shows the demodulated signal. This is obtained by dethreading the received signal using the same PN code and performing majority voting to recover the original message. As you can see, the demodulated signal matched the original message signal, demonstrating successful transmission and recovery.